Hi and greeting to everyone. Now this is the second part of the the subtopic reaction of organic compounds. Now in this video, I'm going to explain about intermediate. But what is intermediate? Okay, before we begin, here's a little recap. In the first video, I already explained to you what is homolytic cleavage and heterolytic cleavage and what is the difference between these two. In this video, we are going to focus on LOC and D, which is, like I mentioned before, it's all about intermediate. Intermediate is referring to free radicals, carbocations and carbanions, and we are going to compare the stabilities of carbocation and carbanion by using the inductive effect of alkyl group. Okay, before we go more further, so let's talk about reaction. So we always know reactions involve like A plus B and it will produce C. So A and B is the reactant, C is the product. Okay, we all aware with this. In the middle here, okay, there's something formed which is not stable. Okay, we rarely talk about it. Okay, but it is there, so we call it as intermediate. Okay, it is a substance that form after the reactions of the reactant, but before the production of the product, and it is not stable and have a short half-life. So that is intermediate. So let's learn more about intermediate. Now intermediate, like I mentioned before, it is unstable and highly reactive. And in organic chemistry, we have three types of reaction intermediate. Okay, reaction intermediate, which is carbocation, carbanion, and free radical. Now, what you have to do is that you have to learn to identify and untuk mengenal, okay, what is carbocation, what is carbanion, and what is free radical. So let's begin with carbocation. What is carbocation? Now, carbocation consists of two words, which is carbo and cation. Okay, we know that cation, okay, is a positive ion, whereas carbo is actually comes from the word carbon. So we can say that carbocation is a carbon that is positive. There are four types of carbocation that you have to know. We have this. This is known as methyl carbocation. And we have this one. This is primary carbocation. Then this one. This is known as secondary carbocation. And the third one is this. So this is known as tertiary carbocation. Okay, now I would like to talk more about this. Okay, methyl carbocation doesn't, the carbocation, okay, so if I can show you, this is what we refer as carbocation, the carbon that become positive ion. Okay, itu adalah carbocation. Okay, so the methyl carbocation, it doesn't attach with any alkyl group. Okay, so that's methyl carbocation. Again, methyl carbocation, it doesn't have alkyl group. Okay, okay, for primary carbocation, okay, it has one alkyl group here. So that's why it is named primary carbocation. The carbocation attached to one alkyl group. Primary carbocation. Secondary carbocation. Okay, this carbocation attached with two alkyl group. Okay, and then tertiary carbocation attached with three alkyl group. Now, in case you're wondering, what is alkyl group? Okay, so alkyl group, dia macam alkane. Kalau alkane like CH4, however, alkyl group, it is losing CH3 because it will become substitute. So for this, I will explain more when we learn in chapter 5. Okay, so another example is CH2, CH3, then what else? CH2, CH2, CH3. So this is named as methyl. So that's why you see methyl, methyl memang CH3, ethyl, and also propyl. So that's why kalau you tengok ini, kita namakan dia methyl carbocation. Okay. Now let's take a look at the stability. Now, in terms of stability of carbocation, okay, so the most stable carbocation, if you ask me, is the tertiary carbocation. Okay, tertiary carbocation. Oops, sorry. This should be secondary. And this one should be. Okay, so like I mentioned before, okay, tertiary carbocation is the most stable. Now, you might wonder why. Okay, because tertiary carbocation has more alkyl group. Okay, so this alkyl group, okay, stabilize carbocation. Okay, stabilize carbocation. The more the alkyl group, the more stable the carbocation. And that is why tertiary carbocation dia paling stable lah if you compare on all of yang carbocation lain. Okay, so again, for carbocation, it is referring to the carbon that become positive ion. Okay, so we are done with carbocation. Let's proceed with the second intermediate, which is carbanion. Okay, so this is carbanion. What is carbanion? Also consists of two words. Okay, so consists of two words, which is anion, and also cup is referring to carbon. So anion is referring to the negative ion. So basically, carbanion is carbon yang jadi negatif. Okay, so sama juga kita ada 4. Okay, we have 4 types of carbanion. So this is named as methyl carbanion. Okay, now this one, okay, the C negative, the carbanion with one alkyl group classified as primary carbanion. This one, secondary carbanion. And this one, tertiary carbanion. Okay, so sama juga classification dia, how it is done. The carbanion, like tertiary carbanion, it must have 3 alkyl groups attached to the carbanion. Okay, kalau di secondary, means it must have two alkyl groups attached to the carbanion. Alright, so this is carbanion, carbon that is negative. So now let's take a look at the, what we call this, the stability. Okay, carbanion, okay, if we look back at carbocation, okay, it is said that the more the alkyl group, the more stable the carbocation. However, it is totally different in carbanion. Okay, totally different in carbanion, where, okay, if I can write, okay, so where actually alkyl group akan menyebabkan carbanion tidak stable. Okay, of stability. So in this case, carbanion, okay, carbanion paling stable adalah methyl. Okay, the most stable because it has less alkyl group, whereas your tertiary carbanion is least stable. Okay, so in this case, alkyl group make carbanion, okay, less stable. So it is totally vice versa. It is totally vice versa to carbocation. So you can pause for a moment, and after that you can continue to learn the next intermediate, which is free radical. So what is free radical? Okay, free radical form from homolytic cleavage. Okay, homolytic cleavage and only involve non-polar bond. Okay, this one you can refer back to the part 1 video. Okay, so free radical undergoes, like I said, it is formed from homolytic cleavage reaction, and then for this one, okay, kita memang fokus kepada carbon sahaja. Sama juga, there are 4 types of free radicals. Okay, there are 4 types of free radicals. We have methyl free radical. Okay, we have primary free radical carbon. Oh, I forgot to write the word carbon because it is on the carbon. Okay, free radical carbon. And then we have secondary free radical carbon. And lastly, we have tertiary free radical carbon. Kena tulis full carbon. Okay, free radical carbon. So the symbol for free radical is big dot like this. Okay, itu adalah simbol untuk free radical. Now, how about in terms of stability? Okay, in terms of stability of free radical ini dia punya stability hampir sama dengan carbocation. Okay, where the more the alkyl group makes it more stable. Therefore, okay, we can say that tertiary free radical is the most stable among all these 4 free radical. Okay, tracing order of stability in free radical. Okay, so just remember carbanion sahaja yang berlainan sikit. Okay, tapi carbocation and free radicals, they are stable because of the existence of the alkyl group. Right? There you go, all the intermediates. Now, let's do some exercise to assess your understanding. Okay, so you can get this exercise from your notes. Now let's take a look. In the first exercise, arrange the following species in order of increasing stability. Explain. Okay, so this one we have methyl. This is methyl carbocation. Okay, CH2+. Kemudian, the middle one, okay, this is the carbocation that we are focusing on. So you have to look around it. Okay, how many carbon it attached to? Okay, so dia ada satu alkyl group, dan satu lagi alkyl group. So this make the second molecule as tertiary carbocation. And then for A, kalau kita buka dia, okay, if you cannot see like this is a condensed one, right? So you can expand it. CH2, CH3, positive. Okay, so as you can see, it only has one alkyl group. So this is primary carbocation. So they ask you to arrange, right? Maka kita arrange lah. So we have CH3+, and then we have CH3, CH2, CH2, CH2+, and then we have, this one, the big one, CH3, C, CH3, C, CH3, CH3, positive here. So this is the tertiary. Ini dia punya order. So mesti label ya, increasing order of stability in carbocation. Okay, tu satu. So ini kita punya markah lah, satu markah. Usually where the mark goes, the mark will goes to this and this one. And then explain. Senang sahaja, very simple, because this one has more alkyl group. Itulah dia. Okay. Now let's take a look at B. Okay, B, if we classify, this is methyl. Okay, this is methyl carbocation. Okay, this one cuma ada satu alkyl group. So this is primary carbocation. This one has 1, 2. So this is secondary carbocation. This one ada 1, 2, 3. So this is tertiary carbocation. Okay. So ini semua sama jugalah dia punya increasing order of stability in carbocation. So what is the reason? Same thing, because this one has more alkyl group. Okay, now we're done with this. Let's see the next one. Now, which would you expect to be the most stable free radical and carbanion? So you can pause and then decide, and then you can, after that, look at my answer. So when we're talking about free radical, of course, like I said, the more the alkyl group, the more stable the free radical. So we know this is the least one, confirm lah. Okay, so which one yang lagi stable? Now, if you cannot see, like I said, you can draw. So like this one, CH2, can expand it. And then this one, C, ada H, ada CH3, dan ada CH3. Okay, so dia punya alkyl group ini 1, ini 2, ini cuma ada 1 sahaja. So this is primary carbocation. Sorry, carbocation pula. Ini adalah primary free radical carbon. Okay, jangan buat short form macam ni. Ini adalah secondary free radical carbon. So, mana satu yang paling stable? The answer would be this one. Okay. So, kalau you tengok structure dia sama sahaja ya, dekat sebelah ni, cuma sebelah ni carbanion. Then of course, carbanion dia mesti ada less alkyl group baru dia stable. So, memang senang untuk pilih. Jawapannya adalah ini. So, there you go. 3 intermediates that you have to know. We have carbocation, we have carbanion, and also free radical. So usually in exam, they will ask you how to identify. I mean, not how to identify, like they give you something like this and you identify it. Okay? So that's it for part 2 for intermediate. Now you can continue with the next part of this subtopic, which is type of reactants. Thank you.